Hey guys, this is Alex,
And Emily.
and we're back with part 4. We're going to be covering some intermediate Revit skills today. So the first thing we want to start with is to look at the model that we've been working with for our in-class assignments. We're going to cover some of the techniques on how to export your views, as you will be doing this next Thursday during the in-class assignment too. So in order to export a plan from Revit, you want to have everything in your viewport set up the way that you'd like it to export. So in this case, I think we're going to go with some post shade walls for our floor plan ground floor. And we have all of our hatches in that we'd like, as well as all of our room tags. Once everything looks good, we can choose to add a crop view. This crop view, when added and made visible, will only export what's within its boundaries, making sure that we're not going to export the full screen and that our quality is going to be as high as possible. So now that we have those boundaries selected and we like what's in our frame, we can go ahead up to File and go to the Export tab. In Revit, when you're exporting drawings, you can either choose the option to export as a DWG file or as some sort of image. Really depends on what you plan on doing with it. You can certainly put it in CAD as a DWG and continue to alter the line work or change some things. Since we're pretty satisfied with our design directly from Revit, we're going to export as an image, which will be ready to go as a final drawing, maybe only making some tweaks to it with Photoshop. So that can be found under Images and Animations, and then scroll down to Image. When exporting an image, you want to change your file destination, so we can go ahead to, maybe I'll just place this one on my desktop. We can call this ground floor. And click Save. For our export range, we'll want to change that to the selected view that we have here. Two of the other options are current window or visible portion of current window as well. For this, we're going to use selected view, open up the select. I'm going to go ahead and check none just to make sure we don't have any other views selected. And then scroll down to floor plan ground floor and check that box and click OK. And I'm going to hit no, as I would only like to do this once. Finally, I like to change my image size to typically a minimum of about 3,000 pixels for whatever dimension is longer. So in this case, I'm going to do 3,000 pixels in the vertical direction. For a drawing like this, it doesn't matter whether we use JPEG or PNG. For this, I'm going to use JPEG lossless. And then we should be able to export right there. Once we export our plan, wherever we saved the image, go ahead and open it up here on my desktop. And you'll notice when we zoom in, the quality of the image is still really high, and that was achieved by using the 3,000 pixels. So the other primary view we'll want to show you is going to be an exterior view, or just any sort of three-dimensional view you may want from your model. The same process that we use for the floor plan can be replicated for a ceiling plan, a section, or elevation, using the same process. So in order to export an exterior 3D view, in the ground floor plan, I'm going to create a new camera. I'm going to place it somewhere out on the southwest of the project. So within the boundary of the window, we can drag out our box here to include the entire house. For a view like this, I might like to add a little bit of ambient shadow. See how that looks. You can certainly add the sun shadows as well by turning on your cast shadows. For this, I'm going to leave it off as I would just like an ambient view of my building. Then we're going to follow the same process, going to File, Export, Image, and then Selected Views and Sheets, we're going to select. We're going to hit Check None to take off that ground floor plan that we exported earlier. And since this is the most recent camera that I made, this will be 3D View 8. Click OK. I'm going to also save this one to my desktop. And then this one is almost a square. So whether you make it vertical or horizontal, it should be pretty good with that 3000 pixels. So here's the exported 3D view that I now have on my desktop. So now that we've covered how to export a number of different views, we're going to show a little bit more about topography. So Emily's going to walk through how to bring in a CAD file that has a little bit more complex geometry for an existing topo surface, and then how to make that a model in Revit.
So when we showed you how to make the topo for our tutorial project, we just assumed that the site was flat. That is very rarely going to happen in most projects. So we have some existing topography. And as you can see, if we go into the side right view, all of our contour lines are already hosted to the correct level. This is very important. All we did to get this in here was just import a CAD file using the same process we showed you earlier. So once that's in here and you make sure those contours are at the same level, you'll go to the Massing and Site tab, and you'll create a topo surface. You're going to create from import, and then select import instance. We'll go ahead and click that CAD file that we imported. Now, if the CAD file had more than just one layer in it, this is where you would choose what layer your lines were on. We only have the 5-foot contour layer, so we'll go ahead and leave that selected and hit OK. So as you can see, you can kind of tell that there are now more lines in there and there are points that it has interpolated. So we'll go ahead and finish the surface. And if we put this in a shaded view, you'll see that it has taken our imported lines and turned it into a topo surface. The other thing that we can do with this is Revit went ahead and interpolated between our 5-foot contours after you hide the CAD file in view. We'll click on the topo surface, and Revit interpolated and added 1-foot contours between the 5-foot contours that we had drawn. So we can edit this view property and go ahead and change that at intervals there and the increment from 1 foot to 5 feet. And hit apply. And this will be the 5-foot contours similar to what was in the imported CAD file.
So now the same way that we edited this the flat surface, you can do all those same things with here, except now you'll notice that the points, if we click on them, they will each have a different independent elevation. So what you'll want to do eventually is set up your levels in a file like this when you're working with a custom topo surface. And you'll want to define what your 0-foot elevation or at grade entry level will be. You'll notice this model is almost 240 feet higher than the entry level. So what you'd be able to do here if we exit out of the edit mode and went to the right side here, what we want to do is unpin this and then move the entire surface vertically so that wherever we place the entry level for our building, that would match up with 0 feet at grade. So then anything above it would be increasing positively, and then anything below grade would be going negatively, which would help you to be able to modify those individual points a little smoother. So next we'd like to just sort of introduce the concept of Dynamo, which is a preloaded plugin for Revit. This plugin is very similar to Grasshopper, which would work with Rhino. The key differences with this is that it is internal to Revit, and the way that it works is that it can do a lot of things in Revit that Revit already does, but it does it in a way that is fully automated, making the time a lot less for the user. So in this particular example, we use Dynamo in this project to create a facade panel design that used 2 panels and randomly display them around the facade, creating a depth effect with 2 different materials, one being wood and one being metal. So in our view here, you can see that we have just a standard curtain wall panel. And then we essentially have one that is a different family, just system panel solid, and then one that we're showing as a family facade that we created separately. So if we go ahead and go to the Manage tab, you'll see that Dynamo is all the way there to the right. Since I've already opened it, it's grayed out, but for the first time, you would click that. And then once you have your Dynamo tab open, I like to sort of run my screens half and half so that I can see what's going on in Revit and what's going on in Dynamo simultaneously. And for this exercise, we're just going to show you guys essentially what you do. This model was created in a previous version of Revit, so some of the plugins that Dynamo uses have not been updated to the new Revit 2020. So we won't actually be running this for you guys today, but just quickly showing what the process would be. So similar to Grasshopper, there's a number of nodes within Dynamo that does a series of operations that transforms whatever your Revit object is into what you'd like it to become. So you'll notice here in Dynamo, we have a few different select model elements. So that would be the same thing as referencing a B-rep in Grasshopper. So this first one at the beginning of our string would be to select the curtain wall itself in its entirety. And once that's selected, it will be grayed and it'll tell you what it's referencing here, which is a wall. The other 2 primary pieces that we're going to reference in this script are a code block for making one of the wood panels and then one code block for making a metal panel. So we would essentially select our panel that we would like to be wood and then reference one of our panels that we would like to be metal. Once all of these are referenced, we have all 3 that are referenced. If we had the correct plugins for this year of Revit, all of our nodes here should be grayed out. We shouldn't have any that are red, and all of the yellow ones should be able to reference what they are, making them all gray. And in Dynamo, you can either set it to automatically update within your Revit panel, or you can manually run it by changing to manual and clicking run when you'd like to execute your script. So in this one, essentially what we're doing is telling Revit that we'd like 75% of the panels to be solid, or what we're calling the metal. And then the other 25% would be the wood. So these can be altered by changing the percentages, and then Revit will generate what you tell it to. So after running that and having it work in Revit, can pull up an instance when this was used in a previous project. So here's a model for a skyscraper building and office complex, where you can see that the facade panels are randomized on the facades here. And if we change to shaded view, in this particular instance, it was a colored solid panel versus a glazing option. So the majority of these facade panels are individual curtain walls that are modified in strips. And due to the geometry of this building, it was a number of times that we had to run and execute the script in order to create the entire building facade here. So now Emily's going to show some of the workflow for importing a Rhino model component into a Revit file.
So this was another fourth year project, and you will often get some criticism that Revit can be constraining, can start to limit your design. So this is where using Rhino and Revit combined can really take your project to the next level. So this is a facade panel applied to the upper portion of this hotel here. So it's a linked Rhino file that has been brought into the project, and each one of them is each side is an individual project that is brought in from Rhino. It is the same workflow to bring in a CAD file as it is a Rhino file. So you go to Insert, and then you can import CAD. You'll need to change your file type from DWG to 3DM, and then navigate to where you are keeping that file. The big bonus of importing a Rhino file is that it gives you the ability to snap and place it at the exact location. So I'll just bring in this northeast facade panel here. You oftentimes have to find wherever Revit has decided to import the instance to.
In this case, if I remember correctly, it is somewhere very, very far away.
It will bring it in as a pinned object. So before you would go to move it, you would also need to unpin it to allow that to work.
We're going to give this a second to respond here and see if we can find our thing here. As Emily said, one of the benefits of bringing in a 3DM file is that you can snap them together. So if you have multiple parts of the same building, or even just multiple elements that you'd like to place in your Revit model, such as a maybe central stair or some sort of element that you really would like to be able to custom build in Rhino and bring in, definitely has some advantages to over Revit, using Revit as a native builder. The other thing is that I was able to change the materiality of our imported wall instance. So whether we're using Revit Render for this or something like a Lumion or V-Ray, we are then able to sort of independently select the facade panels and change the material of them. So northeast facade panel, this is what I was importing here, and for the sake of time, I will go ahead and pull this over off of our building and show how you would snap. Sometimes when you bring files in from one program to another, the place that they come in within the Revit space may be very far away from your model. There's a number of different techniques you can use for that, using some of the zoom commands. It's really just something you have to play around with, and it'll change depending on how you have your project set up. So in this case, you can see that I have 6 different panels around the building. So I just pulled one of those 6 off. the best way to start to orient it is to go in a top 3D view. And then you can use your move tool. And we're going to select it on one of the edges to make sure that we're going to get a nice seam. And when we pull over to here by holding Shift, I'm able to get the geometry to almost line up. So I think that this should be flush with that piece. So we're going to go ahead and pull that over. And the way that I modeled this in Rhino was to draw the perimeter of the building in Revit. Basically, I think I just used some detail lines under the Annotate tab in Revit. And then I basically copied that out off screen, and I used my file export option and exported those lines as a DWG file. I then opened that DWG file in Rhino and was able to quickly draw the facade based on the extents of the building. So once I knew exactly where my curtain walls would be, I was able to press this facade skin directly up, being able to tie it into that system. So if we spin around here in 3D, we'll be able to tell that this panel did align correctly in the height dimension as well. If that would not happen, you could certainly always change your model to be a side view, and then you will be able to move that geometry vertically. And oftentimes, if you're placing a much smaller element than this, something that's just going to sit on a floor, you'll be able to actually snap to that floor in your model and place it quite easily in elevation. And then by switching to a plan view, you'll be able to locate that exactly where you'd like it. So now we've covered a number of different Revit techniques for exporting views and some modeling techniques as well. We'd like to cover the two primary ways that most students like to get some renders out of Revit. We pretty much have one option from Revit natively that you guys will all have on your device as well, which is just the default Revit Render. So Revit Render is essentially a rendering engine built into Revit where you can either render with your computer's processor, or you can also send it to the Autodesk rendering cloud, which will be able to essentially render the image off of your computer, allowing you to do other work while that's happening. So Emily's going to walk through some of the render settings and talk about some of the differences between those two different internal rendering systems.
So once you have your 3D view set up and you're ready to render and see what everything looks like, you're going to go to the View tab and select Render. It'll open up the Properties bar there. And when you're starting, you should just be using your basic setting as draft just to get an idea of what it looks like. And you can leave the resolution for screen, but we'll kind of walk you through what a final output might be. So you would put the setting to best, and then you can set the resolution to printer and use a 300 dpi. As you can see, the height and the width there are kind of small, so that would be something else you can play with a size crop, but we'll just leave it for now. Then you're going to look at your sun settings and your lighting settings. So we do have lights in this model that are working, and we also would like to account for the sun. So we'll leave it as interior, sun, and artificial. You would then open the sun setting tab, and you can either do still or you can use geolocated, depending on how you have your Revit model oriented, if that is correct to the location. So we actually did set that up, and this was a project in State College, so it is correct. And then to look at the artificial lights, you can open this rendering dialog box. So we have 4 lights in the model, and you can control which ones are on and off just by selecting individual ones. We rendered this with all of them on, so we'll just leave it as that. But if you did want to control that, that would be the place to do it. You can also change what the sky looks like if you want no clouds, if you want it to be a really cloudy day. Usually leaving it with a few clouds in it is a good place to start. You can leave the adjust exposure alone for now. That's why we recommend using the draft to start with. It'll probably turn out really dark, and you can play with the settings under adjust exposure before rendering a final output. To render inherently in Revit, you would just click render and it would go. We're not going to do that because it would take a really long time, but that is the process that you would do. The alternative is to render in the cloud, which is a faster and better way to go about it. It also saves you some time because you're able to keep working in your Revit model after you send that model out. You do still need to go through all of those steps in the regular render property panel and set all of those up the same way before rendering in the cloud. But if you click on render in the cloud, just continue through this dialog, and then you'll need to play with a little bit of these settings. We'll leave that selected as the view that you're currently in. You do want to leave it as a still image. Render quality, you will change to final. Image size, you also want to change up to maximum. And then exposure, you can leave as advanced. And then you'll click render. And then it will send it to a cloud-based render, and it'll open a gallery system. Up in the top corner, there will be an option that shows that it's rendering. It'll be a little circle that's kind of like floating. If you click on that, it'll prompt you and it'll open up that gallery for you to view. We've already done that. This was the final output that we had. This would be the main one if you have different projects in it. So we'll view this project. This was the final output that we got. It was good enough for what we were working on, but if the final rendering had turned out very dark, you can go back in and adjust the settings in the cloud rendering as well, clicking on the option there. So you can increase or decrease the exposure or change the saturation of the image to your likings. We decided this was good for what we were working on. So it's just a matter of playing with each of these settings. After you do that, it will require you to re-render it in the cloud. Re-rendering only takes about 5 or 10 minutes for it to be done. And usually sending a cloud rendering or a rendering to the cloud takes usually about an hour depending on how much detail is in it, but it's still faster than rendering inherently in Revit. So we'll open up the final post-processed view of this. Just taking into Photoshop and adding a few trinkets on the shelves and some people as well, just to give it a scale to the project. But we were able to take a relatively quick rendering from the cloud and turn it into something with a good amount of detail. We did this with a second view as well for this project. And we're able to apply different materials, so the doors and the furniture. They're similar to the in-class tutorial that we showed as well. And here's the final output for that view. I would say Revit Render and rendering in the cloud is a really good place to start to allow you to see what those materials and what those spaces can be, but there are definitely better applications to take your projects a little bit further. So we're gonna get into that, looking at how Lumion can be used as well.
So now that Emily's done a brief overview of the Revit Render, we'd like to show Lumion rendering as well. Lumion Render is a rather new school way to render. It is a progressive rendering engine, meaning that as you update things in your viewport, there's not really a render time or buffer time to see the results. So just by going on Lumion's website, It is free for students to download. However, it does require some pretty hefty requirements for your computer, having a pretty high processing speed and graphics card. So only the heaviest of laptops and desktops can really run this. But luckily in the Stuckman School, we do have many of the computers can run Lumion perfectly fine using Revit or Rhino. And the trial for students is free. So if you do have a device that would be able to run this software, you can certainly download and try it out yourself. So using Lumion from Revit is a rather simple process. Basically what it does is it takes your model and live syncs from Revit to Lumion without really having to do anything on your end. So once you have a 3D view, so I'm going to go ahead and use our in-class project for this, our house project here. Once you have your view that you'd like to use, you will essentially open Lumion with the 3D view. So I have already installed a bridge to Lumion connection, which is default in Lumion 10, which is the newest version. So you'll notice that is an option in my Revit bar here. And I'm going to go ahead and start that live sync. So any updates that I make in Revit will be reflected in Lumion and vice versa. So essentially, I've now published this model into Lumion, and as I continue to work in Revit, I'll be able to see in real time what's happening in my Lumion file. So I've already opened this model in Lumion and made a few changes, but the process would be the same starting from scratch. So if I go ahead and open a view of the model in Lumion, you'll notice that our file has been placed in this very large environment. So if we go to objects, we're able to see the entire model that we've brought in with the name up here. And if there is ever some sort of issue, you can always re-import your model, which will pull it back in from Revit. Or if you change the file location, that's also a very handy thing to know. So Lumion essentially works sort of a fly-through program. So by using the WASD commands keys on your keyboard, you're able to fly through your model and look at any side and even sort of adjust your height as if you're just sort of flying through this environment. So I'm going to go ahead and work on some of the exterior of this house in Lumion just to change a few materials and show you guys some of the benefits of Lumion. So you'll notice right off the bat that we have grass here. If you go under the landscape editor, we are able to change the landscape in our scene. There's a variety of different options. I typically use grass as most of my projects have been in urban areas that have some sort of grass, but there are definitely options to suit any project. Lumion is also a great tool for working a little bit more organically, especially from all the constraints that Revit has. So some of the features of Lumion is that you can actually change the height and size of different things. So if I want to go ahead and make a small brush here, I'm able to just adjust this landscape by using a brush, which is something that you can't really do in Revit or Rhino or any other modeling program quite the way you can do it in Lumion. You can also use a paintbrush to draw on water, add ocean. You can paint different textures onto your ground. So if you wanted to have some different types of grass, you could certainly change those as well as the brush size and speed. So in this particular model, the topography surface that we made in Revit is a little bit taller than where our pool water is. So in order to see our pool water, we need to take this model, and I had to move it vertically 1 full foot upwards, just so we could see the tip of that water surface. If I move that back down, you'll notice that the water is now conflicting with this grass material, and we won't be able to see that in our render. So since I'm just trying to get a view of the backyard, by moving that up 1 foot, it works very well. So sometimes this might be a good idea to extend your topo surface out pretty far in your Revit model. So it'll just create a nice plane so you won't see the default grass in Lumion, depending on what you're trying to get with your render. So with our building here, in order to change materials, we can go to the Materials tab here on the bottom left-hand side. The Materials tab will let you hover over any material in Revit that you have defined as something different. So as I build up my Revit model, I'm constantly replacing those assets for the materials. And what that allows me to do is to change everything independently once I get to a program like Lumion. So you'll notice as I'm touching the top of this table, or even the water itself, these materials act independently of one another. If I would have used the default material that Revit gives all walls and all floors, they would all change together and I would not be able to use a variety of different materials. So you notice with the house, I've already changed a few things. So whenever you click on a new item, such as the facade, you're able to open up this materials library. There are 3 main folders, one called Various that has a lot of the outdoor components, one that's indoor that has a lot of your different types of common indoor materials, and then you also have some outdoor ones like bricks, roofing, different types of metal. So for this one, I was using a outdoor wood. You can certainly change to any size material and any color that you would like. So essentially these tiles represent what the pattern will look like on your exterior. So if we wanted this to be some sort of brick house, we could certainly choose some different bricks or even some stones. And if we were to put on some bricks, and let's say that we don't exactly like the scale of these, we can go ahead and double click on that material. This will open a number of different options for us. We can change the color of that material. We can also change some of the appearance things like gloss and reflectivity. And one of the most important is being able to change the scale of the mapping. So as the texture will map to your object, you can make it smaller or bigger to fit whatever the look is that you need to go for. Make your render match what you'd like it to be. And then once you're done editing that material, you're going to want to hit the check mark to save your changes. So that materials tab can work for everything. We have water, we have different sidewalk finishes for our pad here. Be able to change the linen on these chaise lounges. We could go to fabric, pick any different fabric that we'd like, and that'll update in the chairs, as well as these chairs. As you see, I have not created 2 separate materials in Revit. So you will need to be aware of how many materials you're creating if you would want those 2 to be separate. So I'm gonna go and change this back to our wood appearance. I was using this one. So now we've touched on the materials and the landscape. Lumion has an extremely large library of objects that you can place into your model. So some of these things like the chaise lounges, tables, or even some of the other elements within the house itself can be placed directly from Lumion. So if we were to go to indoor components and then click the place command, we open a huge library of different things that we can place. And these will live live in our Lumion scene file. So some of these elements are as small as tables and chairs. You even have a lot of things as specific as different electronics, kitchen items, other entourage you may want to use to build up a scene. Tons of stuff like lighting for exterior and interior, different plumbing fixtures, tons of different pieces of furniture. And these are just under the indoor library. So we also have an outdoor library. One of the biggest libraries is the nature library. So this is where you can find hundreds of trees that you can cycle through. And once you find some trees that you like, you're able to place these anywhere in your model. One of the biggest benefits of using all of these objects native to Lumion is that when you place them, we'll place a cluster of grass. And then come down closer to the surface here. All of these elements will render a shadow, and it'll all be native to Lumion. So it will really significantly cut down on your times for post-processing and photoshopping things, all while keeping your images super realistic. One of the other biggest things that you'll want to do is to change your grass surface. And under various, we have 2D and 3D grass. So I'm going to go ahead and pick a nice 3D clean cut grass right here. So this is going to go ahead and change your surface and add on that grass. So now if we go really close to the surface, you're going to notice that the individual blades are starting to actually show up here. With this, we have tons of options where we can even adjust the individual blade length. We can change the different rotations, the curliness of the grass, really get in there and modify it to make it look exactly how we'd like it to look for our render. In Lumion, we also have really complex settings for sun and environment. So in order to get a photorealistic rendering out of Lumion, we're able to change our sun setting and see those changes reflected live in our model. So we're able to change the angle and sun height all from this weather tab. So I'm going to go ahead back to this view back here. So this view does face north, so we are going to have a shadow on the backyard from the house at all times of the day. But I'm going to go ahead and pull that sun back up and just modify it to be a little bit more late in the day so we can maximize our sun and show the sun pretty high in the sky. Once we have a view that we really like, let's say I'm set on this view here, I'd like to be standing here. We can go ahead and go to the photo. And then by using the right click on your mouse, you're able to look around and really define where you want yourself to be. You're also able to automatically edit the eye level. So I'm going to go ahead and automatically set that. We're going to go ahead and set that to 5'6". We're also able to adjust the focal length here to zoom in or out, depending on what extent we want of our image. Once we have something that we like, we can store the camera, as you have 20 different slots to store renderings for your project. So I'm going to go and store that camera there. In the top left here, we have a lot of different style options as well as special effects. So under the style options, I'm going to pick something like a realistic. So you'll notice now the view looks a lot different. Under this realistic style, it has added all 9 or so of these special effects that you see here on your left, including something called Real Skies, which is a 360-degree environment that lives sort of just in this view. So if we go ahead and double click on that to open this up, you can see that it has selected a real sky. And we have many, many different options for this. But for this, we'll just use what they have. And in order to match the sun setting to where it would actually be, we want to make sure that we change that heading to be coming more or less from the front of the house, since this back part will never actually be directly illuminated. So we're also able to change a lot of different things and add more effects. So some of the effects that I always add on my architectural renderings are some of the different options, making sure that it looks more realistic. So one of those is 2-point perspective, which will make sure that all of your vertical lines are vertical and are not distorted by the viewpoint. Another effect that I like to add, which can add a lot of depth to your image, is God rays under sun. We certainly don't want to overdo this, so I typically only put them on a slight bit just to show some ambient light coming from the direction of the sun. There's certainly many different options in here, and you can find what works for you. There's many options, including a styrofoam option that can even override all of the options that you've put in for materials. So once you have your image all set up and you like the way it looks, in order to render this, you go down here to the green button, click on that to render your photo, and you'll notice we have 4 different options for resolution. I typically use print, or if I know I'm going to be printing it very large, I may even use poster. In this instance, I would use print. just before I'm going to do that, I'm going to add one more thing in. So let's say I really want a tree over here. So I'm going to go back into my build mode and then go to objects and then nature, and then click the place. I'm going to go ahead and grab a few trees to bring them in, add a little bit more context to my scene. Be aware that there also are clusters of trees that you can use to provide a lot of context in your background. So if I place trees back here and over here, we won't be able to see the horizon on either side. That'll significantly increase the believability of your render. So I'm going to go ahead back to photo. And now that we've added these trees, I don't think I like the God rays anymore as they're distorting the leaf pattern. So I'm going to take that off. So if this is ready to render, I'm going to go to render photos and render the print size. Typically, these renderings will take maybe 1 to 5 minutes depending on the complexity of your scene. As it renders, it samples different lighting effects to make sure that the lighting is matching where the sun's coming from and how it should reflect off of all of your surfaces. I'm going to go ahead and cancel out of this once I can, and then show a couple things that we've done using Lumion for our projects. One important note, you always want to make sure you save your Lumion scene file independently from your Revit file, as it is a separate file that needs to be saved. And then every time you open Revit, you will reopen that scene file in order for the live sync connection to work. So within the past few years, we've used Lumion for a number of my projects. So as we showed the couple from Revit earlier, here was a rendering from the project that had the facade panel option on it. This would be a double height interior hotel space. We've also used Lumion for a lot of exterior scenes. In this one, you can see the clarity of some of that vegetation and landscape work when you really add in a lot of context to your scene. And here's another exterior view of that hotel project. You can see there's a lot of landscape buildup. There's also a lot of Photoshop work done in here with some of those mural walls and other things that you can see in the background. So whether you use Revit Render or Lumion Render, there's definitely advantages and disadvantages to both. It really depends on where you want your project to come out with, what graphic style you're seeking. For the week-long assignment, you can choose either to try out the Revit Render, the Lumion Render, or if you're unable to use either of these softwares, we would also be able to use a 3D view, so something like that exterior view that we created earlier. In an example like this, we'd probably want to export it in a hidden line mode, most likely not with any shadows, or with the shadows turned down significantly. But in a view like this, you'd be able to export it and then use the 3D view and add some color and texture just by using Photoshop. Okay, Emily, I think we got through everything we wanted to for video 4.
Yep.
So thank you guys for watching, and we'll see you next time.